Hey there, everybody. Welcome in. Today, we're going to be taking a look at Eureka Math and Engage New York's Grade 4, Module 3, Lesson 5 problem set. And in this lesson, we want students to be able to multiply multiples of 10, 100, and 1000 by single digits, and then try to recognize some patterns that go along with that goes along with what happens when you multiply by tens, hundreds, and thousands. So let's go ahead and hop right in. If you're enjoying these videos, please drop a like and a follow. Really helps me grow the channel, and I really appreciate all of your support. So let's go ahead and get started. Number 1 says 2 times 3, and we have this place value chart, and the directions say, draw place value discs to represent the value of the following expression. So we're looking at 2 times 3. So if we're thinking about what multiplication means, we have a number of groups, and we have size of the groups. So in my ones place, because 2 and 3 are both ones, I'm going to go ahead and draw 2 groups, and 3 in each group. Now, my answer here is going to be how many total objects are in the ones place, and there are 1, 2, 3, 4, 5, 6. So 2 times 3 is equal to 6. 2 times 3 in the ones place, so 2 times 3 ones is equal to 6 ones. And then over here, we just have it vertically, 3 times 2, or 2 times 3 is both equal to 6. Now we're going to use sort of this idea here that 2 times 3 is equal to 6, and that's going to help us out with the rest of these problems. Because if you take a look at number 2, we see 2 times 30. And what we know about 30 is that it is 10 times 3. So if I had 3 ones, I could shift them over to the tens place and they grow by a value of 10. So rather than putting my place value discs in the ones place this time, since 30 is a 10, I'm going to do it in my tens place. Now, I'm not going to draw I am going to draw 2 groups, but I'm not going to put 30 in there because those would be ones. I'm going to do it over here in the tens so I can still draw my 2 groups. And I have 3 in each group because they're tens. So rather than counting by ones this time like I did up here, I'm going to count by tens. So it's 10, 20, 30, 40, 50, 60. So 2 times 30 is equal to 60. 2 times 3 tens is 6 tens. Or again, that is 60. And over here we have it vertically, 30 times 2 is equal to 60. Now down here we have 2 times 300. So 2 times 3, and down here I'm just going to write hundreds, is blank. I'm going to go ahead and draw my place value discs now in the hundreds place. So I still have 2 groups with 3 in each group. And I'm going to count by hundreds this time. So 100, 200, 300, 400, 500, 600. The 2 times 300 is 600, or I could write it as 2 times 300s is 6 hundreds. Again, just in standard form, 600. And over here vertically, we have 300 times 2, or again, 2 times 300 is equal to 600. So we should start to notice a pattern here. So from 2 times 3 is equal to 6, I did that here in the ones place. 2 times 30 is equal to 60, which is 6 tens. 2 times 300 ended up being 6 hundreds. And now we're going to do 2 times 3,000. You might already catch on to what you think 2 times 3,000 is going to be. We're going to write it out here. 2 times 3 thousands. And I'm going to go ahead and draw my 2 groups. with 3 in each group, but since this is 1,000, I'm going to do it down here in the thousands place. So 2 groups with 3 in each group. Remember, since we are in the thousands place, each of these objects represents 1,000. To make 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. So 2 times 3 thousands is 6 thousands. So we really do have this like leading digit stays the same in all of these instances. So 2 times 3 was 6. 2 times 30, we start with a 6 with a 0 for a 10 and a 0 for a 10 in my answer. In number 3, I'm still able to think of it as 2 times 3 with this leading digit of 6, but since it's 100 and hundreds have 2 zeros, I have 2 zeros over here in my answer. Same down here with the thousands. I'm able to think of it as 2 times 3, which is 6, but since I'm multiplying by 1,000 and thousands have 3 zeros, 3 zeros are going to come along in the answer as well. So really the pattern we want to be looking at is using those basic facts that we know, and then sort of multiplying by 10 if we need to, 100 if we need to, or 1,000 if we need to. And we're going to take a look at that in these examples right here. Number 5 says find the product, and we don't have those place value charts to help us anymore. So what we're going to do is we're going to use our knowledge of basic facts and then multiply by either 10, 100, or 1,000, whatever we need to do. So in this case, we're looking at 20 times 7, and I'm allowed to think of this as 2 times 7. 2 times 7 is 14. And then I could think of it as times 10, or this 0 really just kind of like comes along for the ride to make 140. Let me illustrate this maybe a little bit better in letter B, where we're doing 3 times 60, and I can think of 60 as 6 times 10. And this 3 would come down, and I can do 3 times 6 times 10. 3 times 6 is 18, and then 18 times 10 is equal to 180. It's really the same idea because I can think of this as 18 times 1, and anything times 1 is our other number, and then the 0 is coming along for the ride to make 180. 3 times 400, I'm going to think 3 times 4, which is 12, with these 2 zeros in my answer to make 1,200 or 12 hundredths. 2 times 800, 2 times 8 is 16, and these 2 zeros are coming along, so I end up with 1,600. 7 times 3 is 21, but 7 times 30 is 210, that extra 0. 60 times 6, I'm going to think of this as 6 times 6, which is 36. And this 0 is coming along because it's not 6, it is 60. So we're multiplying 6 times 60. So we're multiplying by a 10. 400 times 4, I'm going to think of it as 4 times 4, which is 16, times 100, because we're multiplying by 4 hundreds. So 2 zeros come along for the ride to make 1,600. 4 times 8,000, I'm going to think of this as 4 times 8, which is 32. And I'm multiplying 4 times 8 thousands, so I need to make sure I end up with 32,000. The number of zeros should match in most instances, and you'll probably see one down here with letter L where there might be an extra 0. So if you're multiplying by 1,000, you should really have 3 zeros coming along for the ride, like in letter H. If you're multiplying by 100, you should have 2 zeros coming along for the ride, like in letter G. And when you're multiplying by a 10, like in letter E, really that 1 0 is coming along for the ride. So if I have 1 0 in my problem, I'm multiplying by a multiple of 10, I should end up with a 0 in my answer. Multiplying by a multiple of 100, I should have 2 zeros in my answer. If I'm multiplying by a multiple of 1,000, I should have 3 zeros in my answer. Letter I is 5 times 30. So I'm going to think of this as 5 times 3 tens. 5 times 3 tens is 15 tens, or 150. Here's where it gets a little bit tricky, because I just told you that you should have the same number of zeros, but you need to be careful, because when I multiply 5 times 6, I get 30. And this 0 comes along for the ride to make 300. Now you might be saying, whoa, you just told me that I should have 1 0 along for the ride, but I see 2. But 5 times 6 is 30. So this 0 here in the tens place is kind of satisfying what this 5 times 6 is. So you need to be careful. You can't always just rely on counting the number of zeros. You need to have a good understanding of those basic facts and then put the 0 onto the back. So it doesn't always work like that. Same thing here in letter K, where we have 5 times 400. Where I'm allowed to think of this as 5 times 4, which is 20. Now notice, before I even add these zeros, 20 is part of my basic factor. This 0 is part of the basic fact of 5 times 4. And then these two zeros come along to make 2,000. Okay, you may be saying, oh, I only needed, for my problem, I should have 2 zeros come along, but there's 3. Again, this 0 is from the basic fact of 5 times 4. So we didn't really have that instance in, let's say, letter G, because 4 times 4 was 16 and then 2 zeros. So I hope that clarifies why you maybe sometimes will have 3 zeros. It's not really part of multiplying by the 100 or the 1,000. It's more so part of the basic fact. And you'll see it over here in letter L, where we have 8,000 times 5. My basic fact, 8 times 5 is 40. And then these 3 zeros come along to the ride to make 40,000. Really, I have 4 zeros here, but the 0 in 40 is part of the basic fact of 8 times 5. So don't always rely on bringing those zeros along or just counting the amount of zeros that you should have. You need to pay attention if your basic fact ends in a 0, if you're multiplying by 5. And I think these designers probably made J, K, and L all end in zeros to try and point out that fact. Let's go ahead and move on to our word problems here. Number 6 says, Brianna buys 3 packs of balloons for a party. Each pack has 60 balloons. How many balloons does Brianna have? Very typical style multiplication problem. And what we need students to understand is that this word packs here is really like a code word for groups. A pack of something is a group of something. So she has 3 packs or 3 groups of balloons for a party. Each pack has 60 balloons, and each is such an enormous word with these multiplication word problems, because when you see this word each, that almost always tells you the size of the group. So now we have our number of groups, which is 3. We have the size of our group, which is 60, and we need to figure out how many balloons does Brianna have in all of those groups. So, I could draw a picture here where this is, maybe I shouldn't use circles because we're looking at balloons. Use like these rectangles. So here's a pack of balloons, here's a pack of balloons, and here's a pack of balloons. And each pack has 60. So I have 3 equal groups of 60. So I can go ahead and multiply. 3 times 60. Similar skill to what we were just working on. 3 times 6 is my basic fact, and 3 times 6 is 18. And we're multiplying by 6 tens. So I multiply 18 by 10. And to do that, I just bring the 0 along to make 180 balloons. Got 2 more problems here on this next slide. Number 7 says, Jordan has 20 times as many. So we're going back to some old skills that we've looked at before. 20 times as many baseball cards as his brother. So for every one baseball card his brother has, Jordan has 20. His brother has 9 cards. So we want to know how many cards does Jordan have. And again, 20 times as many means I'm going to multiply by 20. And what am I going to multiply 20 by? The amount of cards his brother has. Again, for every one card his brother has, Jordan has 20. So if he has 9 cards, we need to multiply that by 20. So again, same idea here, where we have 9 times 20, or 9 times 2. I'm able to think of it as 18. And we're really doing 9 times 2 tens, so this 0 needs to come along to make 180 baseball cards. And finally, we'll take a look at number 8, where it says the aquarium has 30 times as many fish. That same sort of verbiage as we see in number 7, with times as many. 30 times as many fish in one tank as Jacob has. The aquarium has 90 fish. So we need to solve for how many fish Jacob has. So we're not going to multiply 30 times 90 here. Okay, let's read it again. The aquarium has 30 times as many fish in one tank as Jacob has. So however many fish Jacob has, the aquarium has 30 times as many. So J is Jacob. So the amount of fish that Jacob has. And then it tells us that the aquarium has 90 fish. So the amount of fish that Jacob has times 30 is going to be the amount of fish that the aquarium has, which is 90. We're solving for how many fish does Jacob have. So something times 30 is equal to 90. So here I need to think about what I would multiply by 30 to get 90. And I need to use my understanding of how to multiply by tens, hundreds, and thousands, and some of those basic facts. When I look at this 3 and I look at this 9, I should be thinking, okay, what times 3 is equal to 9? And I take a look, I have a 0 here and I have a 0 here. So it's not going to be any sort of like multiple of 10, 100, or 1,000, because that's provided to us uh, in our word problem. So something times 30 is equal to 90. The answer here would be 3. 3 times 30 is equal to 90. Or another way I could think of this is, if I have a missing factor problem, something times 30 is equal to 90, I could think of it as division. 90 divided by 30 would equal J in this instance, and we know that J is now equal to 3. So Jacob has 3 fish. Not 4. Excellent. Again, if you are liking these videos and you want more of them, please feel free to drop me a like. Subscribe to the channel really helps me continue to grow the channel. So thanks again for tuning in, folks. I appreciate it. We'll see you next time.